when error is added to the data. Okay,
During transmission of data.
during transmission. Okay, so during transmission of data, when the data is moving from the sender to the destination, so there may be, so when it is traveling through the link, so there may be possibility of the data got changed. Okay, so that is error means here what is the data that is sent, it is not same what is received. Okay, in that case we can tell there is a error in the received data. Okay, so always the amount of error should be less, so then only you can tell the received data, or it should not be there, then only you can tell that the accuracy. Okay, the accuracy of the data you can tell, so it is having good accuracy. If accuracy is going down means, so there is the number of error, or the rate of error is increasing in the received data. Okay, so here what are the in the module 1. Okay, module 1. So during a discussion of different types of transmission impairments, if you recall, so I told how exactly the noise is added to the signal. Okay, whenever the data is moving, so here error is nothing but, in the technical term we call it as noise. Okay, so when the data is moving, noise is added. So that is due to different causes. Noise is due to different causes that we have already discussed. Okay, so now we'll focus on, so where exactly uh, it is going to be detected and it is corrected. Okay, so as of now you can just see the sender, whatever the data want to send, so it will be correct. So consider I am sending the data, I am the sender, I am sending this data. Okay, so during transmission, consider, so this data is changed from 1 to 0, then 0, 0, 1. Okay, and this is received at the destination. So now it is destination should know, so to check how, or is it any error, is the error is there in the received data. Okay, is it any error is there in the received data, then how the destination or the receiver is going to identify that, what is the technique is required. Okay, he cannot just do something else with the received data. Okay, for that there should be some technique added at the sender itself. Okay, sender itself should add some technique to detect that error at the destination. Okay, so that we are going to discuss. Okay, here we are going to use some technique. Okay, at the sender, along with the data we are going to add some extra bits. Okay, so this extra bits, how many bits to be added, all that you are going to learn in the technique. So this redundant bit, extra bits, so this is extra bit. Okay, so you are going to add to the original data and you are going to send, and this is transmitted through the transmission media. Okay, consider when it is transmitting, so once again the same thing happens. So instead of 1001, it is 101, and consider the redundant bit is as it is. So now the receiver or the destination can check the data received is correct or not. How the destination is going to check? So here we have a extra bits. Okay, so these extra bits are added, or it is having some relationship with the data. Okay, so we have some method to calculate how to add these extra bits. Okay, so now when the destination is going to apply that particular method to check is it any error in the data. Okay, so if there is any error, so definitely using the technique it will show how many number of bits got corrupted. Okay, so bits got corrupted, that will be calculated, and there are some technique, using those techniques you can recover this error. Okay, that is called correction. Okay, there is a difference between detection and correction. Are you getting? So detection means you will be able to identify which bit got error. Okay, or more than that, in error detection you are going to identify is it the data is correct or incorrect, or is it any error is there. So that is only thing you are going to check in error detection. Okay, you are not going to worry about how many bits got corrupted. Okay, or what is the position of the bit. Okay, that is not part of error detection. Okay, so that will be taken care using error correction. Okay, so error correction you need to identify how many bits got corrupted. Okay, knowing that only you can correct those bits back to the correct value. Okay, so this is some basic concept you need to understand. So the main concept, that is how to add these extra words. Okay, how the receiver is going to make use of that extra bits or redundant bits to correct the errors. Okay, not all the methods are going to correct the errors. Okay, so some of the methods that can correct the errors. If the number of bits like corrupted, if it is very large, sometimes it is not possible to correct. Instead of that, what is a simple solution is, it can tell to the upper layer to resend the data. Okay, if it is small amount or to some the number of bits got corrupted, if it is less, that can be corrected. Okay, if whole data is got corrupted, then instead of doing all this, so you can just tell the sender to resend that particular data. Okay, so now that process depends on how many bits got corrupted. So we'll just go in detail. And also one more important thing is, there are some application, it does not require for all the application error detection and correction. Okay, if it is a video audio, if there is some loss of data or some changes in the received data, okay, there are some application, those are all tolerable. Okay, those are all tolerable, and it will accept the received data, and it does not it is not going to affect much with the received data. Okay, so error detection and correction, it is more important for text data. Okay, it is going to change the meaning itself. Okay, here I have sent, what is this value, 11. Okay, it is changed to 1 year. You can just see the, just due to change in one bit information or corruption of one bit, so there is a complete change in the information received. Okay, if it is with respect to audio video, okay, if one particular frame is deleted or if it is corrupted, still that type of applications are tolerable. Okay, from this what you need to understand, so this error detection correction is more important for text data, and other applications like video audio, those applications are tolerable for some small amount of errors. Okay, so let me just go to the slides. Okay, so at the end of this course, this chapter, you will be able to detect the errors, and also you will be able to correct the errors. You are going to get a problems in this chapter. Okay, so it is like I'll be giving some problem if this is a data sent and it is received, and what is the extra bits, how you are going to calculate. Okay, what is the extra bit should be added. So all that you are going to learn in this subject, in this chapter. Okay, if any queries, you can just ask me in between. Network must be able to transfer data from one device to another with acceptable accuracy. Okay, so we cannot ensure always 100% accuracy depending on the application. So the accuracy can be accepted either with a small changes in some applications, it is acceptable. For most application system must guarantee that the data received are identical to the data transmitted. Okay, so it is required to ensure that what is the data sent and what is received should be identical. Anytime data are transmitted from one node to the next node, they can be corrupted in passage. Okay, that is when it is moving through the link. So possibility when the node get corrupted, I mean when the data get corrupted when it is transmitting. Okay, so corruption means there is error added to the data, noise is added to the data. So many factors that can alter the one or more bits of the message. Okay, so here once again we have classification. Is it one bit is got corrupted? Okay, types of errors. Okay, so we have two types of errors. One is one bit error. Okay, where only one bit got error in the received data, and another one we have burst error. That means sequence more than 2 bits got error. Okay, so that is one important thing. So data can be corrupted during transmission. Okay, this is one important point you need to remember when data get corrupted. Some application requires errors to be detected and corrected. This word is very important. Some means not all the applications. Okay, for some applications the accuracy is very important. Okay, so in today's class let's go in detail to understand about types of errors. Okay, and redundancy, what is the meaning of redundancy, and we'll go through the what is the difference between error correction. Just a minute. Okay, so detection and correction, then forward error correction and versus retransmission. Okay, so this one I already told when exactly it is going for retransmission. So these are just important topics you need to understand before going for the technique. Okay. Then we have a method where you are going to learn about the correction, detection and correction. So that is called as coding. So what is coding and types of coding? So this modular arithmetic is not part of this, not part of syllabus. So here types of errors. There are two types of errors mainly. So when bits flow from one point to the another point, they are subjected to unpredictable changes. Okay, subjected to unpredictable changes. You cannot know what is the changes is happening, how much it is, or how much changes happened in the received data. So of interference. Okay, when the signal, because obviously there will be an error. Okay, obviously there will be, because of when the data is transmitting through like consider if these are all the channels, so there may be possibility of interference between this signal and the signal that is traveling through this link. So due to that also it may create the error. And also we have discussed so many other causes for the noise added to the data that is transmitting to the uh, destination through media. Okay, so here interference means there will be interfering of the signals from this channel to this channel. Okay, whenever it is traveling, so there will be interference between these two signals. Due to that also it may introduce us the errors. So here interference can change the shape of the signal. Okay, when the shape of the signal is changed, so instead of like this, okay, if it is changed something like this, okay, what is the meaning of this? It may be, it is going to, maybe this is for representing 1 and this is for 0. Okay, it is changing the meaning of that data itself. Okay, interference can change the shape of the signal. So we have discussed what type of signal, how it is done, all that in the previous chapters. So next two types of errors. One is single bit error, where there is only one bit got error, and burst error. So what is the meaning of single bit? So only one bit in the given data is changed. Okay, whatever the bits you are going to change, so among that only one bit got changed, either from 1 to 0, okay, or from 0 to 1. So there is a diagram for that, you can just see. Okay, consider this is the data I want to send. Okay, so during transmission, so this particular bit, 0 is changed to 1. Okay, so this is called single bit error. So detection of single bit error is very easy compared to detection of burst error. Okay, so burst error means two or more bits in the data have changed. Okay, so more than one bit got corrupted, or it is changed from 0 to 1 or 1 to 0. So let me just show you that diagram, you can just observe. So this is a sequence of data I am sending. Okay, when it goes through the transmission media and it is received at the receiver side. Okay, so there are set of bits got corrupted, you can just observe. So here how many? 4 bits got corrupted. Okay, so more than one bit, that is 2 or more than one bit, we call it as a burst error. So now what is the technique you are going to learn is, so you need to check which bits got error among these Okay, which bits out of these 8 bits, okay, out of these 8 bits, which are the bits got corrupted or it is changed. Okay, identify that using error detection. Once it is done, you will be learning technique to correct those errors. So here burst error occurs more than a single bit error. Okay, so most of the time uh, the cases of occurring single bit error is very less. That is due to the duration of noise we cannot expect. It is only for one bit. Okay, so it is not only for the one signal, it will be for, okay, so we cannot expect only the duration of noise is only this much. Okay, so it may be, most of the time it will be more than that, the duration of the noise will be more than this. So in that case the possibility of more than one bit got corrupted. Okay, it will get corrupt more than one bit. So it normally depends on the number of bits got corrupted or how many errors introduced in the data. It totally depends on the duration of the noise. Okay, how long that noise was there in the media. Okay, so noise duration is directly affecting the number of bits got affected. So I'll just give one example here. Okay, so when noise affects the data, the noise also affects the bits. So data is nothing but it is group of set of bits. When I tell it is affect the data means there are some bits got corrupted. Okay, number of corrupted bit depends on data rate. I think data rate and noise duration. So the text is going down. Okay, so you just remember here the data rate and noise duration. Okay, so how long, like how much data is got corrupted, it depends on this. So how fast the data, or what is the data rate and what is the noise duration, accordingly you can tell what is the total number of bits got corrupted. Okay, so let me just give, I think I don't have in the slide, so here I'll just give one example for, so how many bits got corrupted. So consider here the data rate is 1 kbps. Data rate is 1 kbps. Okay, this is my data rate. And noise rate here, it is 1 noise rate. It is 1 by 100 seconds. Can somebody tell what is the number of bits got corrupted in this case? How many bits got affected with this data rate and with this noise duration? So data rate is 1 into 10 power 3 bits per second, and what is the noise? It is 1 by 100. Okay, so out of 100 there is 1 bit got corrupted. Okay, so in that case, if this is the case, if this is the data rate and if this is a noise, okay, what is the number of bits got affected here? So it is 10 bits. Okay, so these are simple questions you need to understand. So how data rate and noise durations, or so this is 100 seconds, 1 by 100 seconds, that is every 100 seconds there is 1 bit got affected. So in that case, based on this data rate, the number of bits got corrupted according to this is 10 bits. Similarly, you can calculate, okay, you just tell me the answer. If the data rate is 1 mbps, okay, these are all just basic things you need to know. This is coming. Okay, so if the data rate is 1 mbps and noise rate is noise rate, I will consider the same noise rate. Okay, I will change only the data rate. Okay, 1 by 100 seconds. Can you tell what is the how many number of bits got affected? Quickly, somebody answer. So 1 mbps is the data rate. Here I have just changed the data rate. So when I am changing the data rate, obviously the number of bits got affected should be more. Yes, what is the answer? How many bits got affected? Am I audible? No? Am I audible? Someone respond. So this silence tells.
Yes, ma'am.
Uh, can you answer? Somebody? What is the answer? How many bits got affected here?
20, ma'am.
Calculate, man. Others? How come it is 20? You people are taking lot of time to tell the answer. So here the data rate is
Is
1.
10,000?
Yes, the answer is 10,000 bits. So 1
Yes.
into 10 power 3, 10 power 6. Okay, this is the data rate. And what is the noise rate here? So 1 by 100 second. Simplify this. What you will get? So it is 10,000 bits. Simple calculation. It doesn't require even calculator in case if you are searching for calculator. Okay, just note down these important things. So in the notes, many of you are asking notes. See, notes, you first time read once at least the textbook. Okay, notes I will give. So my notes will be like it is for exam point of view. Okay, for knowledge point of view, you need to learn from the subject. At least read once textbook. Make a habit of reading the things from the textbook. Okay, you will get the notes. So that is for the preparation of exam. Okay, what are the important points you need to write? All those things I will give. Okay, if I am giving for understanding purpose, my notes will be like textbook only. Okay, so for that reason, you just as and when I complete the topic, try to read from the textbook. Okay, so this is how you need to calculate how many bits got affected based on the data rate and noise duration. Okay, you may get like some question like mm, like how you are going to calculate how many bits got corrupted. Okay, so what are the factors? It depends number of bits got corrupted. Okay, purely it not only it depends on the noise duration, it depends on the data rate, so that you need to remember. Okay, so next we'll move on to redundancy. Okay, this is most of the time I already use this term, and also here this is very important. This technique is very important for error detection and correction. So here what it tells redundancy, the central concept of detecting and correcting errors is using redundancy. So here redundancy means adding some extra bits. Okay, adding some extra bits along with the data. Okay, I think you just recall whatever I think I have shown the PDF. Okay, so adding extra bit instead of sending only this data, I'm just adding some extra bit. So these extra bits are used for detecting the errors, and those extra bits we call it as redundant bits. So some extra bits along with the data have been sent, okay, for the purpose of detection and correction. So did anybody checked for the data link layer? Okay, you just go back and check either TCP IP suite or OSI model layers. So we have three information. Normally for network layer or physical layer, we'll be having only two information. One is the header part is added and the data. Okay. So what is one more additional added at the data link layer? Can somebody quickly answer? So that shows how much you understood the layers. This is network layer, and also the other layers also follow the same thing. And this is data link layer. Data link layer is having one extra information. Quickly, I want the answer. Who knows the answer? I told even when I was doing that particular concept. Yes, anybody tells what is one more information? Do you agree? Is that there is one more information at the data link layer other than header and data? Will you agree at least? I will tell what is the answer. For that also no response. Okay. So there is a information added at the data link layer alone. Okay, that is called trailer information. Okay, so this trailer information is indicating these extra bits. Okay, so whatever the extra bits I am talking now, so that is added at the data link layer for the purpose of detection, and this is called trailer information. This extra bits are used for the purpose of detection, error detection and correction. Okay. So these are the small things you need to keep on observing. Okay, it is not just read something from the PDF. It's not enough because you have one more subject, advanced subject of data communication, that is computer network and security. You will be learning in the IO semester. Maybe I think in the next semester itself. So these are the fundamentals you should know. Okay. So just keep observing some small things. So that will create interest in your studies. Okay. So these extra bits are called redundant bits. So now who is going to add these redundant bits? Okay, redundant bits are added by the sender. Okay, so there will be a relationship between this data and whatever the extra bits it is added. Okay, there will be a relationship. It is not just add something and send. No, there is a relationship. And who is going to remove this trailer part? Okay, or these extra bits? It is removed by the receiver. Okay, first it is used for error correction and okay, error detection and correction, and later when it is delivering to the next layer, it will be removed. Okay, the presence of redundant bits allows the receiver to detect and correct the errors. Okay, so you should be knowing now onwards, anywhere in any technology, anything, if you use this redundancy means it is like extra things. Okay, so with respect to error detection and correction, if you go for database, redundancy means the duplicate. Okay, the same data if you are storing multiple times, that is called redundancy. Okay, so here this is extra information is stored or added to the data. So now quickly we'll go to the, still I have, okay, I'll just take 3 more minutes, and before 5 minutes I will leave. So error detection and correction. So error correction is more difficult than the detection. Will you agree? Will you agree? So I think I told already what is error detection and correction. See, identifying error is very easy. So how many bits got corrupted? Okay, correcting those bits, it is very challenging. So that's why error correction is always more difficult than the detection. What is the meaning of error detection here? What is the meaning of error detection here? So here we are checking whether any error has occurred or not. That's all. We are going to check, is it any error is there in the received data? Okay, if it is answer is yes, that's all. Okay, you are not going to do anything in error detection. So you are going to check for the answer yes or no. If there is no error, you will be getting the answer is no. Okay, because you are going to run some algorithm. So that algorithm is going to give yes or no answers. Okay, if you are getting no, there is no error. If you are getting the result as yes, that means there is error. Okay, that's all done by the error detection method. Okay, it is not going to worry about any further things. So further things means, so we are not interested in number of bits corrupted. That means if it is a error detection method, it is not going to worry how many number of bits got corrupted. Okay, and what is the position of that bit. It's not going to worry. So all that it is taken care at the correction, error correction. Okay, so here we need to know exact number of corrupted bits. Okay, you need to find out that new means like your the algorithm. Okay, algorithm is going to find out how many bits got corrupted. Okay, and also location of the bits in the message. Why we need location of the bits in the message to be identified in error correction? That is obvious, no? When you want to correct, if it is 001 is sent, and if you have received 001, so among these, in the error detection, you will come to know that there is a error yes. Okay, in error correction, it should find out how many bits sorry, how many bits got corrupted. Okay, according to that algorithm, it tells us there is one bit got corrupted, and location should also be specified. Okay, because it has to correct this error. So this 0 is changed to 1. Okay, some technique should be used to identify is it should be 1 or 0. Okay, that is taken care at the error correction. Okay, so here two important factors to be considered in error correction, that is number of errors and what is the message size. So even message size also it matters. So is it I have time only 5 minutes is there. Okay, let me just go. I will explain this coding in the next class. So there is a technique called block coding. Actually, there are two types of coding. My PPT is not fully visible. Okay, one is called block coding, and there is one more method called convolution coding. Okay, these are the techniques. So we are going to discuss all these techniques in the next class. At least I'll try to complete block coding in the next class. Okay, so after that we have block coding. Then we have some other method, CRC, that is commonly used method, efficient method that can be used for error detection and correction. Okay, so we'll discuss those methods in the next class. So I think it will be delayed for your next class. I will stop the class. So if you have any queries, you can just ask me.